All right, so this is a new one, y'all. This is 9.1. The composition of functions. All right, so this is some new terminology here. So first we'll look at what we call F composed G. Of X. Now, y'all, that is a little circle there. It is not multiplication. This little circle we call a composition operator. So what this really means, F composed G of X is the same thing as F of G of X. So this is where a whole function is in the domain of another function. Okay. So to work this problem, we would work G of X first. Then put that value into the F of X. So it's almost like you're doing a two-step with two different functions. You're going to figure out one function. Once we get that result, we plug it into our other function. And y'all, that's the same thing with our G composed F of X. That would be like G of F of X. So on this one, we would work the F of X first. Then put that value into our G of X. So to me, these are like two-part functions, okay? We're going to evaluate one function, get that value, put it into our other functions. You know, they're not too bad once you get the hang of these. So let's start out with, we're going to let F of X equal negative 3x minus 1. G of X will equal x squared minus 2. So for this problem, they want us to find F composed G of a negative 3. So we sometimes call this in fog because it looks like fog, right? All righty. So remember, using this terminology up here, this would be like finding F of a G of a negative 3. So first, we're going to put our negative 3 into the G function. Once we get that result, we'll plug it into the F function. So first, put negative 3 into the G function. So y'all doing that, we're going to be finding g of a -3. So remember, g of -3, since I got an x squared there, that's going to be -3 squared minus 2. All right, so I got to multiply my exponent first. So -3 times -3 gives me a +9 minus my 2. And then 9 minus 2 gives us 7. So since g of -3 gave me 7, I now got to take that 7 and put into the f equation. So our second step puts 7 into the f of x. So notice, I'm taking the function value to give me into the g. We got a 7 out of that. Now the 7 goes into that f. So that means we're going to be finding f of 7. F of 7 will equal -3 times my 7 minus 1. All right, so order of operations, multiply first. So that's going to give me a -21 minus my 1. And then our -21 minus 1 will give us a -22. So f composed g of a -3 in the long run equals a -22. So y'all, like I said, they're not too bad. You just got to keep up with your functions on this, okay? So now this next one, they're going to go to g of f order. So let's say we're given f of x equals a 3x plus 4. My g of x is going to equal x squared minus 3x minus 5. Y'all, they want us to find g compose f of 6. All right, so remember, this one is like finding g of a f of 6. So remember, when we said we had g of f, we're going to work the 6 into the f function first. Once we get that answer, we'll put that into the g function. So the first thing we got to find is f of 6. All right, so we will take our f equation. So let's see, f of 6 will equal 3 times 6 plus 4. I also, let's see, 3 times 6 is 18. So I'm going to get an 18 plus 4. 18 plus 4 gives us 22. All right, y'all. So since f of 6 gave me 22, I'm now going to put that 22 into my g function. So that means we're going to be finding a g of 22. Well, that might be a pretty big number since I got a square there, right? So g of 22 will equal 22 squared minus 3 times 22 minus 5. Oh, y'all, so let me break out the calculator for big numbers like that. All right, so 22 squared gave us 484. Minus my 3 times 22 will give me a 66. And then bring down your minus 5. And also, let's see what that's going to give us. 484 minus 66 minus 5. Looks like I'm getting 413. All right, let me let one in real quick. All right, so that means g of f of 6 equals to 413. All right, y'all, let me flip for our next one. All right, so we're going to be given f of x equals 5x plus 4. G of x is going to equal x to the third. They want us to find f compose g of a -3. So f compose g of -3 is the same thing as finding f of g of -3. So remember, you're starting on the innermost and working your way out. So first, we're going to find g of -3. Once we know what g of -3 is, we'll put that into the f. All righty, y'all. So g of -3, take that g equation, x to the third, put in that -3, and raise it to the third power. Oh, y'all, so let's see, that's what, -3 times -3 times -3. So 3 negatives will definitely be a negative. And then 3 times 3 times 3 gives us 27. So g of -3 equals -27. So that means we're now going to find f of that -27. It's just like you keep substituting these answers in here. So then we take this f equation and put that -27 in for that x. So that would give us 5 times -27 plus 4. And y'all, that's a trick on them, just following the order they're giving you, okay? So y'all, 5 times -27 gave me -135. plus our 4. So remember, we're adding unlike signs. So the answer will have the sign of the larger number. And then 135 minus 4 gives me 131. So that I get a negative 131 for our answer. Okay, so that's your trick on these. Look for what order they're giving you. Evaluate. Once you get that answer, put it into the other function. So y'all, we're going to play with the domain again, but we're going to learn a different way to write our domain. We're going to use what we call interval notation. So far we've been using set builder notation where we say x such that x is a real number and x cannot equal whatever number. So in interval notation, to represent all real numbers, we use parentheses from negative infinity to positive infinity. So remember, negative infinity, as far as I can go out to the left in the negative direction. Positive infinity is as far as I can go out to the right in the positive direction. So this is how we represent all real numbers in interval notation. So what we got to figure out is how do we exclude numbers? So y'all, here we go. To exclude numbers from the domain, we use the union. So this is sort of like and. Okay. Now, let me let y'all recall something. If you've ever done let's say on a number line and you did less than or equal versus less than, when we use a bracket, this bracket means it includes the number. Parentheses exclude the number. Okay, so these brackets you would use if you had equals in it, like greater than or equals, less than or equals. You would use these curvy parentheses to exclude that number because it wouldn't have that equals part on it, okay? Now, the only exception is these infinities. The reason infinity has curved parentheses is because there's never a stopping point with infinity. It keeps going and going and going and going. So, y'all watch this. For example, if we wanted to exclude any number A from our domain, we would write so remember it starts at negative infinity. So if I'm excluding this number a, I would put my a with a curvy parentheses and then my union. And then I would start at the a and go towards positive infinity. So remember, since I got curvy parentheses around a, that means it excludes that number. So this is how I would write a domain that included all real numbers except for a. So since it would go from negative infinity up to a, but not include a, remember this meant and it would include the set of numbers that started after a, but once again, it don't include a because of the curve, and then it heads towards infinity. So let's play with one example. So on this example, let's find the domain of f of x equals 1 over x plus 3. All right, y'all. So what number would we exclude from this domain based on this fraction? Hang on, let me pull my chat up. All right, perfect. -3 is the only number we're going to exclude. So to exclude that -3, our domain will start at negative infinity. It includes all these numbers except that -3. So we're going to union around that -3. So now since we unioned around -3 with the curvy parentheses, it has been kicked out of our domain. And then we would continue to positive infinity. Now, later on in life, if we kick out 2 or 3 numbers, we have to use 2 or 3 unions. You'll have a union for every number we kick out, okay? All righty, y'all. So you're about to see why I needed to give y'all a little bit of this interval notation. All righty, so watch this. On these examples, so they're going to give us all of this at once. So they want me to find f of g of x and g compose f of x. And y'all guess what? They want the domain of each. So let's see what they're giving me for f of x. They're giving me x plus 24. For g of x, they're giving me x minus 24. So y'all, what I'll do is I'll figure out what f of g of x will give us. Its domain. Then we'll knock out g of f of x and its domain. Now, the one thing you're going to notice on this, they did not give us any numbers on this one. So since they didn't give me no numbers for my g of x, we'll put the whole g of x function into the f function. So y'all, I'm going to start with the f of g of x. So remember, that's like finding f of g of x. So we need to take the g of x function and put it into the f. So here's f. F is x plus 24. For that x, I'm going to take the x minus 24 and replace that x. Okay, so watch this. So we know it's going to be sum x plus 24. But we're going to replace that x with the x minus 24. So that's going to give me x minus 24 plus my 24. Notice I've now put my whole g into my f. So y'all, the question is, simplifying that, what would y'all get on that? Oh, perfect. Because y'all, these like terms cancel out. Negative 24 plus 24. So all we get is x. So now here's the question. What would be the domain of this f of g of x? So do y'all have any restrictions on these functions here? So good job. No restrictions. So our domain would be from negative infinity to positive infinity. So our domain is basically all real numbers still, okay? Just remember, we're writing it like this now instead of using the words on it. So no restrictions, all real numbers. So y'all, now we got to look at the G compose f of x. So this time I'm going to take my f function and throw into my G. Okay. So remember, the main function is the G. So it's going to be sum x minus 24, it says. But remember, in place of that x, I've got to take this whole function and put in there. So I'm going to have a x plus 24 minus my 24. Okay, so on the first one, I plugged in this. And on this one, I plugged in that. So here, I put the G into the F. Here, we're putting the F into the G. All right, so, and y'all look at this. Since they use that plus 24, minus 24 on this one, guess what? 24, negative 24, cancel again. So all this gives is a x. And y'all guess what? No restrictions on this domain, which means our domain, once again, will be all real numbers. So we'll go from negative infinity to positive infinity. Now, y'all don't worry, they're all not going to be canceling and getting the X like that one did. That's just because they had one equation minus in 24 and one adding 24, okay? All right, y'all. So here we go. Find, I'm going to call this fog and goth. F compose G of X and G compose F of X. And y'all guess what? The domain of each. Okay, so fx is not too bad. F of x equals x plus 2. And y'all guess what? G of x is not going to be x minus 2 this time. Woo! G of x is a 3x squared minus 5x minus 2. So y'all, that G function is pretty big there. So let's start with our fog. F compose G of our X. So remember, we're going to put the G into the F. So y'all look here, F is just an X plus 2. So X plus 2. But here's my X, and guess what? This whole function is going in for that X. So we'll have our 3x squared minus 5x minus 2. So that whole function is the x, and then we still got our plus 2. So let me highlight my function I put in again. So remember on this one, we put G into F. And y'all remember, this F composed G of X is the same thing as F of G of X. And you couldn't do nothing to the G of X. That's why we're putting that whole thing into our F. So can we go further? Oh, that should have been equals there. So you can definitely go cancel the 2's out. So yeah, y'all, those 2's cancel. So we get a 3x squared minus 5x. So how about that domain? All right, y'all, any restrictions? So here's our stuff we was playing with, no restrictions. So we're going to go with all real numbers. So negative infinity to a positive infinity. All right, y'all. So we done the F of G. So now we get to play with G of F of X. So remember, this would be like G of F of X So since I can't do nothing to the f of x, I'm going to put that whole function into my g. But y'all look here. G is 3 times sum x squared minus 5 times the x minus 2. Then remember, in place of these x's on the g, I'm putting the f of x, which is the x plus 2. And that x plus 2 has to go into both those x's, okay? So, little more algebra here. Number one priority is inside the parentheses, but we cannot do anything inside the parentheses. So my exponent is next priority. But y'all, that exponent 2 follows that x plus 2, okay? So what we're going to do on the side, we need to figure out what x plus 2 squared equals. Now, that's not going to equal x squared plus 4. Remember, when you got a binomial like this with 2 terms being squared, you got to write that twice. And then you're going to FOIL that. So here we go. X times x is x squared. X times 2 is 2x. On the inside, 2 times x is 2x. And then y'all finally, that 2 times 2 gives us 4. So these are the same sign, so they don't cancel. They're going to double. So then I get a x squared plus 4x plus 4. So that's what I'm going to replace the x plus 2 squared with, is what I got over here when I FOILed it. So I got my 3. Then I got my x squared plus 4x plus 4. And y'all, I'm going to bring everything else down. Minus 5 times x plus 2 minus 2. So remember, all we did over here on the side was figured out that exponent. So now, cannot do nothing inside the parentheses still. So we need to distribute. We need to distribute a positive 3 through the first parentheses. Then we need to distribute a negative 5 through the second parentheses. And then we'll bring down that negative 2. So remember, since this 5 has a negative in front of it, we do have to distribute the negative. So y'all, let's try this. 3 times x squared gives us a 3x squared. 3 times the 4x gives us a 12x. And then that 3 times 4 gives us a 12. All right, so here we're going to distribute a negative 5 times x is a negative 5x. The negative 5 times 2 gives us a negative 10. And then y'all at the very end, bring down that minus 2. All righty, so looks like we got like terms everywhere. So let's see. I'll start us out because I'll bring down this 3x squared. Oh, look at that. Let's see. Because my like terms were the 12x minus 5x. So that'll give us 7x. Oh, look at that, Hannah. You did perfect because that 12 and -10 and -2, all that basically cancels out. So our final answer, good job, is a 3x squared plus 7x. And guess what? Any restrictions on this domain? So good job, no restrictions. So that means it goes from -infinity to a positive infinity. All right, y'all, but you know, from the experiences in the past, all these answers ain't going to be -infinity to infinity. So we're going to break out the fractions on the next one, okay? You know, these kind of problems, that's when you start to get into that fun algebra, right? Following all them signs and keeping up with them. All right, so once again, we're going to find our fog and our golf. So our F compose G, G compose F, and guess what? The domain of each. All right, y'all, look at this. F of X is going to equal 3 divided by 1 minus 2x. G of X is going to equal 1 divided by X. Let me make sure I got my numbers right. So y'all, guess what? We got two fractions sitting here. So I'm going to start with the fog again. So my F compose G of X. So remember, I'm going to be putting my G function into the F. So F is 3 divided by 1 minus 2 times my X. But y'all remember, in place of my X, I'm putting the 1 divided by X. So let me highlight the function I'm putting in. Was my 1 over X. So we're going to simplify this thing first. Once we simplify it, then we will figure our domains out. But y'all, right off the bat, there's a problem when I got the domain right here because I got a fraction with the denominator in it. All right, y'all, let me let one in real quick. All righty. All righty, so to simplify this, this is what we call a complex fraction. It's when you got a fraction inside of a fraction. So to simplify this, we need this to look like a normal fraction like this, okay? Or like this, something on top, something on bottom, but not a fraction inside a fraction. So this is a complex fraction, so we're about to simplify it. So the first thing I would do to this is multiply 2 times 1 over x. So I'm going to get 1 minus. Now remember, if you want to treat the 2 like a fraction, put a 1 under it and multiply straight across. So 2 times 1 on top gives me a 2 over 1 times x makes an x. So y'all, the trick to this is getting rid of this little fraction here. So what we notice is it's got an x in the denominator. So what we're going to do is multiply all parts by x, because that was the denominator here, okay? So you're going to come over here. Now remember, what you do to the bottom of the fraction, you do to the top. So I'll multiply the top times the x. And then both of these parts on bottom get multiplied by the x. So I'll have the x times 1 minus my 2 over x times that x. Now, watch what happens. These are sort of tricky, these complex fractions. But on top, you got 3 times x, which will give you 3x. On the bottom here, we had x times 1, which will give us the x minus. But y'all, look what happens here. I got a 2 over x times the x. Don't these x's cancel out right here? Those x's cancel. All that's left is our 2, so that the bottom becomes x minus 2. At this point, notice, I got a numerator and a denominator. I don't have all these extra fractions inside of that. So on this style, the trick is to multiply everybody by that denominator. And y'all are probably going to have x's in the bottom like me. So just remember, multiply that x times everybody. Because remember, multiplication distributes over everything, okay? So this is now nowhere that I can simplify this no more. So this would be my f composed g of x. So now let's think about the domain on this one. Right off the bat, you just put a 1 over x into this function. Are there any numbers that x right there cannot equal? Oh, no, I like the 2, Hannah, but that 2 is going to take care of this one right here when we get to that fraction. But what can this x not equal right here? Perfect. This x right here, this x cannot equal 0. And then Hannah did good because she seen this x down here. Since you got a fraction with a denominator and their variables in there, 2 minus 2 would have made that one equal 0. So we also got to exclude a 2. X cannot equal 0. X cannot equal 2. So definitely this is going to be one of those with more than one number in it. Now, here's the trick. We got to go in order from left to right. So if I start at negative infinity, what's the first number I need to exclude? Going left to right. So perfect. It's going to be 0. So negative infinity to 0. Then we're going to union around our 0. Now, From 0, I'm cruising along until I hit 2. So we got a union around 2. And y'all, guess what? From 2, there's no more restrictions. So from 2, I'm heading off towards our positive infinity. So notice all your numbers will be next together, but they'll each have their own little union going on here, okay? And always remember, you're going left to right from the most negative to the most positive. All right, y'all. Well, that was our f of g. So now we got our g of f. So g compose f of x. So remember, this time we're going to take our f function and put it into our g. But y'all look at that. G is just 1 over x. But look here, my x is now going to be a 3 divided by 1 minus 2x. So what we're putting in this time is the bottom. So y'all, this one's not as bad to simplify like this one is. Because there's not a little fraction inside this big fraction like I had here. So on this one, well, since I taught you the LCD on this one, I'm going to do it to this one. But notice on this one, the whole LCD on the bottom fraction is the 1 minus 2x. So what I'm going to do, I'm going to multiply top and bottom by 1 minus 2x. Okay, so I treat this like one whole denominator on that bottom. So we're going to multiply top and bottom by that. So on top, I'll have 1 times 1 minus 2x over 3 over 1 minus 2x times 1 minus 2x. But y'all see what happened on the bottom? This 1 minus 2x and this 1 minus 2x, they're going to cancel smooth out. So let's see what we got on top. I got 1 times 1 minus 2x. That's just going to be 1 minus 2x. On the bottom, well, we canceled all that out. All that's left is our 3. All right, y'all, we cannot simplify that no further. So notice, I'm not worried about the f of g part right here, the g of f, because there's not a variable in the bottom. So y'all, if you notice, the only place where I'm worried about on this is that x right there. So the question of the day, what can that x not equal? So y'all, since that's more equation looking, we could set 1 minus 2x equal to 0 and see what we get out of that. All right, y'all, so to solve this for the x, I'm going to subtract 1 from both sides. I then get a negative 2x equals negative 1. I'm going to divide both sides by negative 2. Well, that cancels, giving me my x. And remember, negative divided negative, make that a positive 1/2. So if we put a 1/2 in for the x, 2 times 1/2 is 1. 1 minus 1 makes that a 0. And y'all guess what? I don't see any other places where we got to worry about our domain. Because remember, I ended up with a 3 on the bottom of this one, which means I don't have to exclude any numbers because that's always going to be a 3 on this fraction. So the only place we were concerned was where we had that x in the bottom. We said it cannot equal 1/2. So our domain will be from negative infinity to our 1/2. Then we union around 1/2 until we hit positive infinity. All right, also a question on that. So that was 9.1. So I'm just going to show y'all a few problems you're going to see on your 9.1 support. And 9.1 support was just getting you back into practice of plugging numbers in. So let me find my function. So on this one, it says find the indicated outputs for f of x equals x plus 8. So for my first one, they want f of 0. So remember, f of 0 just wants me to put a 0 in for the x. So that's going to give me a 0 plus 8. Well, y'all, 0 plus 8 gives us an 8. Then it says, hey, find me f of 3. So y'all, that is on y'all. What is f of 3? Ooh, that was quick. So you did what? 3 plus 8. And that gave us 11. How about f of a negative 6? 2, let's see, because that'd be what? Negative 6 plus 8. So good job. That does give me a positive 2. Then they said, how about f of a negative 11? So what y'all got? Ooh, negative 3. Good job, because negative 11 plus 8. So remember, unlike signs, so larger sign is negative, and then 11 minus 8 gave us the 3. All right, how about this one? F of a plus 7. Oh, good job. Good job. A plus 15. Can I put the a plus 7 in for the x? And then add my 8. And then all you could do really was add the like terms so that you got an a plus 15. All right, then let me see what the second one has on it. On the second one, same thing. Find the outputs. For f of x equals 4x squared minus 5x. So I think this is getting you ready for the one we did a while ago where I had, what, 22 squared and all that fun stuff. Getting used to these x squareds on this. But y'all, this one starts out with an f and 0 also. That'd be 4 times 0 squared minus 5 times 0. So we're just trying to get you a lot more practice at plugging these numbers in. Oh, y'all, so what's that give me? Good job, big old 0, because 0 times 4 is 0, minus 5 times 0 is 0. So that's definitely a big 0. And y'all, anytime you're putting a 0 in and everything's got an X in it, it's always going to be a 0. Then they said, hey, find me f of 3. So that'll be 4 times 3 squared minus 5 times 3. And y'all, I'll show you this one by hand. I would hit that exponent first. So bring down that 4. 3 squared would be 3 times 3 is 9. Then I'm bringing everything else down. Then I do my multiplying. So let me see. I'm showing a 21. So let's see what we get. 4 times 9 would be what? 36. Minus my 5 times 3 is 15. Oh, y'all doing good today because 36 minus 15 is definitely 21. All right, let's see. How about an f of a negative 2? That'll be 4 times negative 2 squared minus my 5 times negative 2. So if I usually get mistakes, it's on one of these with these negative numbers here. So I'm going to bring down the 4, do my exponent first. So negative 2 times negative 2 will give you a positive 4. And then minus my 5 times negative 2. All right, so let me see if I can get, oh my God, y'all knocking these out because 4 times 4 is 16. In this, you're subtracting a 5 times negative 2, which would be like a positive 10, because remember, 2 negatives make that a positive. And y'all, good job, because 16 and 10, perfect, gives me a 26. Oh, what I want here. How about an f of a r plus 2? All right, y'all, so I got 4 times r plus 2 squared minus 5 times r plus 2. So remember, on this one, we got to figure out what that r plus 2 squared is going to equal. And remember, that was just getting you ready so you could foil on my compositions. So that'll be a r plus 2 times r plus 2. So R and R give me a R squared. R times 2 gives us a 2R. 2 times R gives us a 2R. And then our 2 times 2 gives us a 4. Woo! Adding like terms, R squared plus 4R plus 4. So we can now replace the exponent with that. R squared plus 4R plus 4 minus my 5 times R plus 2. All right, so let me see. 4R squared you got plus 11R plus 6. I'm about to see if that girl's right because she knocked that out. Let's see. 4R squared. 4 times 4 give me 16R. 4 times 4 give me 16. Then remember, distribute the negative. So here we distributed the 4. Here we'll distribute the negative 5R and then minus 10. All right, y'all. So the 4R squared definitely coming down. 16R minus the 5R. Those are like terms. Perfect. That gave me 11R. And then let's see, I had a 16. And the minus 10 were like terms. And that gave me a plus 6. Woo, that's a very good job. All right, y'all. So that is your 9.1. So you had like 6 problems on the composition stuff. First 3, I gave you numbers. You're gonna plug them in and then put them into the other function. The last 3 were finding G of F and F of G and the domains, okay? And in your support, we're just getting you ready, finding these function values here, okay? So not too bad. We're just trying to get you good at playing with these function values, especially when I throw these R plus 2s at you and these A plus 7s. All righty, y'all. So, any questions over this? All right, so what I'm going to do, since I don't see no question, I'm going to actually stop our recording.